Okay, so it was requested that I make a quick video on just dealing with the graphs of secants and cosecants. So I wanted to start by looking very briefly at, remember that the sine wave looks like this. And one thing that's really, really important to remember is that the cosecant is just the reciprocal of the sine wave. So kind of tricky, but at the value like, say, pi over 2, the value of the sine wave was 1. So you can kind of see that nice clear value sitting right there. That's the maximum of that curve. Or at maybe, you can also see over here at 3 pi over 2, you can see that minimal value of the sine wave at -1. And those are really important things to me because what I notice is the reciprocal of the number 1 would be 1. So the cosecant wave should intersect the sine wave at those places. But also what you'll notice is everywhere where the sine hits 0, which happens at 0, which also happens at pi, which also happens at 2 pi. I'm not going to list them all because there's too many of them. I have a new computer, and so it keeps shutting off and coming back up real quick. Now, those are where the graph, when I take its reciprocal, would be undefined because, you cannot take the reciprocal of 0. Now, there's an infinite number of these. I'm not going to list all of them. So remember, when we graph the cosecant, what should happen is that cosecant wave should actually touch at the 1 because the reciprocal of 1 is 1 and the reciprocal of -1 is also -1, and it should fit within those bars. And so the actual graph of the cosecant wave you can see is the solid wave that you see right here. I don't know why my computer keeps turning off and on. I'm not sure if it'll show up in the video or not. But that's what the cosecant wave looks like. Now, when you go to a cosine wave, it's going to look a little bit different. Now, the cosine wave doesn't have maximums at those places. The maximum slides over. Its maximums was at 0, and its minimum happened at pi. And so as you slide your way along, the place where it has its asymptotes was at pi over 2. That's where it hits 0. Then it happens at 3 pi over 2. And also similarly happens, maybe we could go backwards a little bit and use -pi over 2. So that's the place where that one hits. And so if I were to turn this into a secant, just like the other one, it should intersect at this peak right here and at this valley, the max and the min. And there we go. The secant wave, I don't know, the computer shut off and came back on again, is going to hit at those values. So that's kind of the root idea that sits behind those things. So what I'd like to do is just go through a couple of problems that I have set up for us on my document camera. So let's just take a look at a couple pieces. I wanted to make this look a little bit bigger so I can see it better. So notice in this first problem, we have a vertical shift of 7, and I've told you guys to kind of always start there. We've got an amplitude of 5, so we're going to go up 5 and down 5. Now again, this first example should be fairly nice. We don't like to have anything attached to x, so I factored out that, and I have pi over 9. So a standard sine wave should fit inside here. Now keep in mind, I'm not graphing the sine, I'm graphing the cosecant. So that's why I made the sine wave dotted, because that's there simply for reference sake, just to kind of help me out. That's going to put an asymptote at the left side, the right side, and right in the middle, because remember, the asymptotes will happen wherever your original graph hits 0. And so what's going to happen is this thing is going to be at pi over 9. And the period is 2 pi over 3, also known as 6 pi over 9, because remember, we have always talked about how you want that common denominator. So if I move over 6 pi over 9, I get 7 pi over 9. Now, this is the first time this has happened in any of the examples that I've given, and I wanted to make sure there was one that didn't come out perfect. So you should see something here. So 1 plus 7 is 8. 8 pi over 9, so cut that in half. You get 4 pi over 9. But something unfortunate happens on this next step, because if shut off again. 1 pi over 9 plus 4 pi over 9 is 5 pi over 9. And if I try to cut that in half, I would get 5 pi over 18. 4 and 7 makes 11. So that would be 11 pi over not 9, but over 18 because I'm cutting in half. And that leaves me with my graph going this way. Now, I did say that I wanted to show you a little bit of something in the graphing calculator. So I'm going to go ahead and do that. Now, I'm going to go ahead and graph the sine wave because if my sine wave works, then clearly my cosecant wave is going to be fine. So I'm going to make sure that I'm in radian mode, which I am. And I'm going to go in here and I'm going to use the window setup that it has. So my x min is going to be pi over 9. My x max is going to be 7 pi over 9. And as far as what I count by, it really doesn't matter at all, but I guess I'll just go from here to here. It was 3 pi over 9. Not that it really matters, okay? Now, as far as y min was 2, and my y max was 12, and maybe I'll count by 5s because that's the gap right here. Now, if I hit graph on this graph, now again, I'm not going to graph the cosecant, I'm just going to look at the sine. Computer shut off again. Okay, so again, 5 sines of 3x minus pi over 3. Now, if I did this correctly, what I just did is I turned my calculator into that box that I've referred to, making sure I typed everything right. And if I hit graph, I should see one perfect sine wave that perfectly fits right within there. And of course, what's kind of cool is if I calculate the value at, like, let's say the number 2, it should say at the value at 2, it should say that it was at 7. And if I calculate the value at, let's say, sorry, I did that wrong. If I calculate the value at pi over 9, it should have been at 7. Well, it's too close to the edge, I guess. Let's try 5 pi over 18. There it is. It sits up at 12 like we knew it would be. If I calculate the value at 4 pi over 9, it should be right down at the bottom of the box, which would be at positive, oh, there was a 7, right there, right in the middle. And so you can kind of check those answers by graphing it and turning your calculator into the box. Now, second question. Again, I went ahead and I didn't want to have every problem have a terrible story. So we started at -2 and we went up 1 and down. My period should be 2 pi over b, which is 4 pi. And my phase shift should be x equals 3 pi over 4. So that's where I start off. Now, I want to make this into a common denominator, which I will make 16 pi over 4. So I'm going to move my way around this. 3 and 19 adds up to 22, so this would be 11. 3 and 11 make 14, so cut that in half, and I'm at 7. So, you know, this stuff just takes a little bit of time. It's a little bit tedious, and it's a cosine wave. So I'm going to go ahead and graph my happy little cosine wave. There we go. And remember, the asymptotes happen anywhere where the original graph hits 0 because the reciprocal of 0 would be 0. So that's going to happen in these two places. So I'm going to have one asymptote at x equals 7 pi over 4. Another asymptote out here at 15 pi over 4. And remember, since this curve is up and they always touch, my secant is actually up here. And then it's down here. And then back up here. Now, I did want to show you once what happens when we go and take the time to try to graph it down here on the standard stuff. So what the first thing that I notice is that there's an asymptote at 7 pi over 4 and 15 pi over 4. So since this is counting by pi over 4s, then 7 pi over 4 would be right here. So there's 8, 9, 10, 11, 12, 13, 14, 15. 15 pi over 4 would be right here. I'm going to go ahead and go backwards and get one more back here in the background at -pi over 4. I know my midline right here was at -2. I just kind of personally like putting that in, although you don't have to. The peak was here at -1 and the valley was at -3. So that's really where that wave should have been. And so my maximal value at 3 pi over 4 was -1. So at 3 pi over 4, it was -1 right here. And then the graph kind of goes up here like this. This value is at 11 pi over 4. 8, 9, 10, 11 pi over 4. It was at the bottom. That's right here. And then it's going to come down like that. And then we can see that every time we move over 8 pi over 4, we're going to get a new one. So if we wanted to come over just a little bit further, we could maybe do one more and put it right here in the middle of this one. So you 1, 2, 3, 4, 5, 6, 7, I believe it's 8 right there, right there. And that's kind of what happens. So we end up with these values at 3 pi over 4. We were sitting up here at -1. At 11 pi over 4, we had that minimal value down here at -3. And that kind of gives you a little bit of feel for what it really should look like. So I'm going to go ahead. Meter shut off again. So what I'm going to do is I'm going to shut this video down for the moment and do a couple more problems on a separate video just to keep each of them kind of short. So that was the basic one. I'm going to do one that's a little bit weirder in the next video. So hopefully this helps. See you in a bit.